Hello, I'm Chance, and today I wanted to do a demonstration on how pressure change can drastically impact the shape of the container that it's in. Originally, I was going to do one where the pressure increased inside the container, like pressure of gases or liquids, increased inside the container, and that would cause the container to rupture. But that could be misconstrued as directions or a tutorial on how to make a bomb. So I won't be doing that. Instead, I'll be doing the reverse, how decreasing the pressure of a gas inside of a container can cause the container itself to implode. And for that, we're going to send it over to Other Chance, who is putting his body in the line of fire for science. Wait, what? So the experiment that I'm going to be doing today can be very easily done at your own home, in your own home. However, if you are a minor, or just please make sure that you have adult supervision, because while this demonstration necessarily isn't dangerous, you can easily hurt yourself. So what you're going to need is, number one, eye protection. Number two, some long-sleeved apparel to protect your arms from boiling water. A dish that will be filled with ice water, and an empty can. Oh, it's cold. Oh, it's very cold. Safety warning. Don't chug ginger ale. Oh. Oh. Oh, I'm starting to feel it. Oh, I'm going to vomit. Oh, give me a second. I'm going to vomit. Oh, this was a bad idea. Oh, this was a bad idea. An empty can. Oh, God. Don't do that at home. Oh, I feel like I'm going to vomit. Anyway, just get it cleaned out a little bit. Thankfully, I didn't vomit, but I did release a lot of gas. Feeling much better after having released the gas that was building up in my stomach. An empty can. Now, what we're going to do, go off camera here a little bit, is put a small amount of water in the bottom of the can. And what we're going to do, come over here, is we are going to put the can on a stove, or use some other form of heating if you would rather not use a stove. We're going to put the can on the stove, the water inside of it. We're going to put some water in this, and some ice in it, so that the temperature of the water is below 0 degrees Celsius. And what we're going to do, I'm explaining it now because I'm going to turn the fan on, and that is probably going to make the audio terrible. What we're going to do is we're going to heat the water inside the can such that it turns into steam. And once the entire can is filled with steam, we'll turn off the heat, use a pair of tongs to move the can, flip it over into the ice water, and we will see what happens. All right, safety glasses on. We have our ice bath, we have our can that is empty, save for a little bit of water at the bottom, and now we turn on the heat, we start heating it until it's steaming, and then we'll flip it over. And this and the part after is where the safety stuff comes into play, you know. Having tongs so you're not touching the hot can, wearing a long sleeve so that when you flip the can over, you don't get boiling water on your arms, and the same thing with the safety glasses and boiling water in your eyes. If you want to try this at home. And again, if you do decide to try this at home, because it's very fun to do, make sure that if you are younger than 18 years old, that you do it with adult supervision. Et voila. For those that don't know, this is the majority of what science is. Waiting. Waiting for your reaction to finish, waiting for your results to come in, waiting for your equipment to do their thing. It's honestly a lot of waiting. But in between the waiting, you get to do the fun stuff. So it is important that once the can starts boiling and steam starts coming out of the can, that you don't do it right away. You have to wait a little bit for the steam to push all of the air out of the can. That is a very crucial and important part in this. So I've tried to do this 4 times in a row. For some reason, it doesn't want to work. So I'm using a different can now. I don't know. Maybe that will have something was up with that can that it was just maybe this can's just exceptionally sturdy. I don't know. More than likely, I'm doing something wrong. But here we go. Attempt number 5. All right, so as you can probably see, I hope, maybe, on the camera, yep, you can see that, it's steaming real good now. So what we're gonna do is we're gonna turn off the heat, grab it with the tongs, and flip it over into the ice bath. In 3, 2, 1. In hell! So as you can see, the can has been crunched. The can has imploded upon itself. Science. Alrighty, so what is happening here, make sure you can see this, is as our can is being heated, we have a little bit of water in there, and there's some air taking up all the space in the can. And as we're heating it, the water, as it goes to 100 degrees Celsius, is evaporating and boiling off. And as it does so, it pushes all of the air out. And so now everything that's left in the can is 100 degrees Celsius water vapor. And so once we tip the can over into our ice bath, then all of the 100 degrees Celsius water vapor very quickly cools down to our 0 degrees Celsius ice bath. And as it cools, its pressure reduces. So it's not pushing on the walls of the can as hard anymore. This gas inside the can is not pushing on the walls very hard. As it reduces in temperature, it reduces in pressure, and some of those stop. But the air pushing on the outside of the can stays the same through the whole time. It's 1 atmospheric pressure. And so as the steam, the water vapor inside the can goes from 1 atmospheric pressure at 100 degrees Celsius, drops down to 0 degrees Celsius, whatever air pressure it's at now, that's much less than the atmospheric pressure of the air around the can. And so as that wins out, as that difference increases, the difference in pressure that is being exerted on the can overcomes the can's structural integrity, and the can is crunched. So yeah, that is how changing the pressure of a gas can have drastic consequences on its container. Thank you for watching. Hey puppies, wasn't that a good demonstration, huh? Come on, give us a sniff. Yeah, you're a good pup.